everyone. Welcome to the VDI and End User Computing Summit. Today's event was organized by the hardworking folks at Virtualization and Cloud Review and Redmond Magazine, who have brought together some of the best independent experts on today's topic. Many thanks to our sponsor, cloud solutions provider and hyper-converged infrastructure pioneer, Nutanix, for making this event possible. And thanks to you for joining us. I'm John K. Waters, Editor-in-Chief of Application Development Trends, and I'll be your moderator for the first of three information-packed sessions. But before we get started, I need to go over a few housekeeping details. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Each of today's sessions will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the summit. We'll do our best to get to all of them. Our sponsor, Nutanix, has provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. As you leave the summit today, you'll be asked to take a short survey. Please take a moment to share your honest opinions. Our editors read every comment, and they help to shape our future events. And last but not least, at the end of the third session, one lucky attendee will be receiving a Surface Pro 7, Microsoft's ultralight tablet. But you must be present to win, so stick with us. Now let's get started with our first session, Top VDI and End User Computing Best Practices. For this session, we've called on writer and analyst Tom Fenton. Tom has a wealth of hands-on IT experience in a variety of technologies, which he acquired over 25 years in the industry. His focus over the past 15 years has been on virtualization and storage. He worked at VMware in staff and senior level positions, and he served as senior validation engineer with the Teneha Group, where he headed the Validation Service Lab, and was instrumental in starting its vSphere virtual volumes practice. Tom wrote the first training course for Horizon, VMware's virtual desktop product, and he is a contributor to Virtualization and Cloud Review and StorageReview.com. And he was my guest on the latest episode of the WatersWorks podcast. You should check it out. I know you're in for a great session, folks. Take it away, Tom.
Hey, great. Thanks, John. Yeah, I really enjoyed doing your podcast, by the way. Really had a lot of fun doing that. My name is Tom Fenton. Yep. My name is Tom Fenton, and I'll be taking you to the first part of this summit. Before we get going, I have to say that I've been involved with remote working technologies for the past 15 years. And I have seen nothing like we've seen in the last year and a half. I mean, it was really interesting. It was transformative. We learned so much with the number of corporations having remote workers and using VDI to enable these remote workers. Over the past 15 years, I've seen a lot of VDI practices that worked well and many that really haven't. I'm going to share these experiences with you. As a side note, I'm not going to be going over things that are readily available, like sizing of desktops, how many CPUs, a task worker needs, things like that. You can get that information, any number of places. What I want to do is kind of dig into some of the other aspects that you might not be aware of, that might be a little bit harder to ferret out, that really can help you with best practices around VDI. Last year, like I said, just crazy. Nearly 2/3 of the Americans reported working from home at some point during the current crisis that we're having. That really is double the figure from the previous year. Virtually everyone with kids reported that their school-age children were engaged in distance learning. The network went crazy. Overall, Comcast, the biggest broadband provider in the U.S., said the first 4 months of the pandemic resulted in about 2 years' worth of expected network traffic growth. And as much as I like to to bag on Comcast as well as the next guy, hats off to them. They did a fantastic job making sure that we were able to work remotely. I mean, we didn't see a whole lot of huge network outages, so they did a fantastic job. They saw their upstream network traffic. These are a lot of that's from remote workers. It went up by 50%. Peak internet traffic in the U.S. rose by 32% overall. In some markets, they saw 50, 60% growth in it. So yes, people are working remotely. At least that's what the network and these polls would tend to indicate. So we need to work smarter. We simply can't work harder. With this surge in remote workers, we really need to use the resources to their full potential. We simply don't have the resources, whether it be hardware, software, and probably most importantly, the manpower to maintain a VDI environment in a suboptimal manner. We don't have the resources to throw at the problems that we're seeing. Even if we could find the employees to fill openings to deploy and support our remote workers and the infrastructure, we don't have enough time to bring these people up to speed or even years to train them or give them the tribal knowledge that we need to support them. So we need to leverage information. Hopefully some of that information you'll get from me today, what we've learned and how to make sure that we're doing the right thing at the right time for our remote workers. We need to make sure they have the right hardware, software, and using it in a really optimal manner. Before I get going here, I need to do just some level setting and kind of describe the parlance I'm going to use and what VDI is and why it matters and some of the challenges it's had in the past. Going to be using some really simplified example during this presentation. A lot of the things I'm going to be talking about, I could literally spend hours, if not days, discussing. So I'm just going to give you a glimpse, a simplified view of them, and then you can, maybe do a little bit more research and work about a deep dive into them. I was really in a unique position when virtual desktops first came on the scene. I was working for VMware when Horizon, their VDI deployment came out, and so I really got to see how it developed out. And to be honest, when it first came out, I didn't understand it. Why would anyone want to use a virtual desktop when you could use a physical desktop? But then as I started to dive into the technology and work with the engineers who developed it, I really began to understand the power and attraction of it. VDI now is a major product line for many, many different companies. Virtually every high-tech company, hardware, software provider has, integrations into VDI. So this is a basic VDI implementation. The heart of it is something called a connection server, and what the connection server does is it allows people from the outside world to connect to resources that are on the inside world, usually in a data center. People can connect to it using a tablet, thin client laptop, what have you. And then they get these remote services. They might be virtual desktops. They might be Windows desktops. They might be Linux desktops. A lot of people using published applications, streaming applications that are delivered via VDI. Most VDI vendors now have cloud desktops that can also be accessed from the connection server. So the end user is, pretty oblivious to what they're actually connecting to. Hopefully that's the whole point of VDI, is to make it layer abstract and they don't have to worry about it. Also, you can use physical workstations, and I'll talk about this in a little bit as well, that are securely inside a data center, and you can access them to remote locations. So back when VDI first came out, vendors tried to sell it cost savings. They had these fantastic calculators that would show you how much you could theoretically save by developing it. I actually had my hand in developing the calculators, and we took some pretty big liberties with how much it cost to purchase, maintain, and manage physical desktops. To be sure, if you had a large call center that ran 24 hours a day, VDA made a lot of sense from a cost perspective. So because you can have multiple shift workers sharing different virtual desktops and didn't cost as much. Now that we've 15, 20 years later, the cost savings on VDI really is valid. It's due to the price of servers have dropped and dramatically, and the number of CPU cores and RAM in a server has just dramatically increased. While the cost per core per gigabit of storage has dropped dramatically. Back in 2005, 2006. The standard industrial standard server was a dual proc server with maybe 8 cores, 128 gig of RAM as a dual proc system. You could host maybe 50, 70 task workers. Now the standard server is a dual proc server, but it has 32, 64 cores. It has close to a terabyte of RAM on it. And on this server, you can host 250, 300 users. You can even throw GPUs in the servers that can be shared between multiple users. So when the cost savings story for VDI started to play out, we came up with, our users came up with different stories that allowed us to expand VDI. And the biggest one was security. Back in the day, I was an SE. Before I went on to call, I'd just pick up a USA Today, and you'd always see someone who left their laptop at a coffee station, at a gas station, and the information on it, these Social Security numbers, governmental records, they got leaked. So with VDI, all that information is stored in the data center. It's securely protected. So security became a big issue. Financial companies, banks, they really liked VDI for that story. Also, me and John were talking about this earlier before the call, business continuity. That back in 2005, we had a couple big storms hit the East Coast, kind of similar to what we're seeing now. And we had these large office buildings that had these workers in it. In 2005, everyone had a PC on their desktop. And you know what? People could not physically get into the office to work. We did have some offices that had off-site VDI locations, and these people were able to continue working flawlessly. So business continuity, desktops are important. Around 2005, people just really didn't understand how important desktop computers were. Now we fully understand that. Business continuity, huge, huge selling point for VDI. One of the cost savings things we did in the early days was manageability, because it is so easy to manage a virtual desktop. You usually clone, best practices to use clones, and so you have one image to patch, to maintain, and then you push that out to everyone else. So manageability is so much easier with VDI. And then one thing that really hit me with the pandemic, that I really didn't think of too much. And I was talking to some people who work in media and entertainment, and these people have big, powerful physical workstations that manipulate the movies, the entertainment that we all enjoy so much. The company that I was talking to is one of the bigger movie producers. And what they first tried to do is have people take these powerful workstations home and do their editing, do their manipulation from home. But they found the problem was the data. They used VPNs to access the data in the films, the frames in the data center. But you start to get jittery networks, and there's a whole lot of information, a whole lot of files that need to come over, and it just didn't work out well. So what they did is they actually took the workstations, relocated them back to the data center, and then used VDI to connect to the workstations that were right next to the data, the files they needed to manipulate. So VDI. This is, what we're going to be talking about, and these are some of the reasons people have chosen to use it. And, like I said, it's just been crazy for the past year. like I said, I'm not going to, get into, right sizing a desktop. You can go to any of the major VDI vendors and they have that laid out. I'm going to go to a little bit a different play on this. And best practices that I'm going to be talking about is how to ensure the end user has the best experience they can. So two goals for best practices for VDI is one is to ensure the end user has the best user experience possible. And the second is to make sure they use the resources as judiciously as possible. And the number one things people complain about is logon duration. We did a survey. We went out and talked to over 400 different people using VDI, and their number one complaint was that it takes too long to log on to a virtual desktop. And another study did an average of all the companies, and they found about 30 seconds is the community benchmark that you should shoot for to have people log on to their desktops. This, in some industries, it's nice to have a login below 30 seconds, but in other industries, healthcare, for example, you need to have the doctors, the clinicians be able to log in extremely quickly. Otherwise, patient care will suffer. So you really need to be aware of this. And to be honest, in other industries, financials, governments, you might have a lot of security processes take place, and there's really no way around that. And it's going to take a little bit longer to have that login for the users. Fortunately, there's a lot of really good tools that help you monitor logon duration, and you can see the logon duration time. This particular tool is pretty sophisticated, and it shows a graph and chart of all the processes that are taking place. How much each process takes, how much CPU utilization that process takes. So there's really some neat tools out there that let us pinpoint, problems that people have when they're doing their logon. Logons can be broken down into 3 different phases. Each of these phases can cause a slow logon. Pre-startup authentication entitlement, that can be slow if the authentication server is overly loaded. Even the VDI client can be a source of slow logins. And during the logon, I have seen user profiles. User profiles, are especially roaming profiles, can really increase the logon duration. Also, application abstraction software, if not configured correctly, can also cause slow logins. The problem with trying to detect the problem with the slow login is, you got a bunch of different log files you have to go through. You have to kind of coordinate the time because a lot of these start out in parallel. They aren't serial. And so you have to, kind of take a look at the times they start and stop. And fortunately, people have written scripts to analyze this and kind of show you them. If you look in the lower right corner, this is one script that I ran, and I found that my group policies were taking 51 seconds in order to go through that. And when I dug into the group policies, I found that I had a bunch of WMI calls that I really didn't need. Once I got rid of those, it only took 20 seconds, 19 seconds for this user to log on. So user logons, just a huge thing end users complain about. Another thing end users complain about, or maybe they don't, is the response time. And in the past, this was really difficult to quantify. People would complain about, I'm clicking my application X, and it's taken forever to get response time, and there really wasn't a way to quantify that. You could look at CPU, you could look at memory, and you could kind of maybe get an idea if it was heavily overloaded. the CPU usage went to 100 and spiked at 100. That might give you some indicators. Everyone knew this was a problem. Fortunately, our friends at Microsoft, they kind of came up with a nice solution where they measure user input delay per process and user input delay per session. These track the time it takes for an application to respond once an item is clicked. They work equally as well for local and remote desktops. Using these counters, you can quickly identify the root cause of a bad end user. Basically, what these counters do is they measure how long any user input, mouse click, keyboard usage stays in the queue before it is picked up by the process. You can monitor these counters using perfmon if you want. However, that can be kind of painful, so there are third-party tools out there that can measure response time. The advantage of using one of these tools, it can track multiple machines at the same time, report on a single dashboard, and even some of the more sophisticated ones, they can use the user input delay to set off a trigger when they detect that user input delay is greater than 100 milliseconds. Then it might allocate more CPU resources to that user, so to mitigate the fact that they're having slow average user input. And I really like this screenshot because it's showing that even though the CPU and memory utilization is low, the user is still having relatively high user input delay. And one of the great things about average user input delay is when you do make changes to a desktop, you can see how this changes the average user input delay. Before, we'd have to just ask the user, so I made these changes, the things seem to work better. They didn't have a way to quantify it. They say, yeah, it seems to, but that only goes so far. But by using these trackers, these counters, you really have a good quantifiable source to it. And one of the more interesting cases that I saw was a vendor, I'm sorry, not a vendor, a consumer used these statistics to say, hey, when we increase the hardware profiles for the virtual machines, the average input delay is decreased. We need more resources. And that's the way they were able to justify having a hardware refresh. So everyone likes to see numbers on it. A tenth of a second is about the limit that people can handle before they feel their system's acting sluggish. It doesn't seem to react instantaneously. Once you get to a 1 second, click, people start to lose their flow of thought. They, start to drift off a little bit, after a second. And once it gets to 10 seconds, you've lost them. They're off doing something else. They're checking their Twitter feed. They're checking the news. They just lose that train of thought. So if you do have applications that maybe going out there fetching data and it is going to take more than 10 seconds, you need to give them some kind of feedback. Maybe a spinning hourglass or a little bar chart that says, yeah, things still are happening for you. You haven't lost the session. All right. So we talked about a couple things on the what users experience. Let's go ahead and talk about some best practices around how to make your VDI environment better. The first thing you want to do is you want to use clones if at all possible. 98% of users can use a clone desktop. Clone desktops takes a master image and clones it to all the user desktops. Using this, you generate the exact same desktop from this master image. And you can be assured that each employee will have the same suite of pre-configured applications that's been fully tested. This saves time in a couple different ways. individual machines, of course, don't need to be created. They don't need to have the application installed on them. And because in a lot of cases, the clone technology lets you boot or clone a running VM, you don't have that a boot up time involved as well. And when you can create clones that quickly, within a second or two, in fact, one vendor went out and they said they could clone over 1,000 VMs in under 25 minutes. So, that's just incredibly quick. So when you can create clones that quickly, you can do some really neat things with them. You can make disposable virtual desktops. So every time the user logs off, that desktop gets blown away and they get a new minty fresh desktop. Because everyone knows one of the problems with desktops, either virtual or physical, is the amount of garbage that people put on their OS. The viruses, registry entries get changed. Desktop's just going to collect this over time. So by using a quick clone technology, a new fresh desktop with all the latest updates, patches in it can be spun up. It does look like I have a question here. Thank you for the questions, by the way. Just put those in the chat box there. And I'll either answer the questions real time like I'm doing now, or I will kind of delay until there's an appropriate time in the session to answer it, or we'll kind of do a wrap up at the end. Great question. By using these disposable clones, what happens to persistent data? That is a great question. It does take some education and discipline on the end user's part. You want to use things like, some kind of roaming profile, end user management software on it that retains this persistent information on it. That is a great question. Yeah. So I store something to my desktop, but if I get a new fresh one, what happens to that information? You are right. It will be removed when the desktop gets recreated. So it does take some discipline and some planning on your part. I used to teach at a university, and the first thing I told the computer scientist students I had was, it's always been about the applications. All computer, all hardware, all software is dedicated to running and delivering applications. No one buys a computer to run Windows. They run a computer with Windows to run the applications. So it's things like remote desktop session hosts, RDSH. It really plays a huge role in this regards by allowing users to stream just the applications to a device of their choosing. It can be a cell phone. You can run a Windows applications on a Mac OS. In fact, when I was at SE, I was doing some healthcare things, and doctors, for some reason, love their Apple laptops, and if you have a Windows application that isn't going to run on the Apple's laptop, they just don't want to hear it. And so published application really is a neat way to deliver Windows applications to a Mac OS or to a Linux system or even to a cell phone or tablet. Application streaming, published applications just streams the application, not the whole desktop. So it doesn't really consume the resources that a full desktop will. And it can alleviate a lot of the problems with a full desktop, such as viruses, registries, people installing unsecure applications on it. One of the major advantages of streaming the applications is you just deploy the application to the users. You can do it real quick. You can just update and patch that application in a central location rather than on each individual desktop. Furthermore, data-intensive applications can be located closer to the data source. Streamed applications are really an important technology in healthcare. They love streamed application. and other verticals that need to deploy applications regardless of the user's platform. They've been around for a long time. VDI vendors have realized this, and a lot of them, in fact, I'd say all of them have a way to do the application publishing using the connection server. Now, let's see, come on, slide, there we go. When people think of published applications, a lot of people just think of RDSH, which entails using Windows Server to stream applications. But I've seen more and more people go to Linux to stream applications because it's really an attractive alternative when you have an application like a web browser that is, that can be streamed from a Linux system, because you don't need to worry about having the Windows Server licenses or the RDSH licenses, the CAL license. It makes licensing a lot simpler when you stream it from a Linux system. A lot of VDI vendors also allow you to stream Windows 10 applications. Probably asking yourself, well, why would I want to stream a Windows 10 application when I can do it with RDSH? Well, you might have a different version of .NET that's running. You might have a Windows UWP, Universal Windows Platform application that simply doesn't work with RDSH. You might have drivers that don't work with a server application. Just a lot of different reasons why you might want to stream Windows 10 applications, and this is a possibility. A lot of people, the majority of people, deliver full desktops for the flexibility it gives the users, but I'm really finding more and more companies choosing to just stream the application to the users. It's a win-win situation for both the user and the IT department. Bring your own device, BYOD. Users can access these Windows applications with not having the overhead of a full desktop. IT departments don't need to support the applications on individual desktops. Again, conserving scarce IT resources. A lot of users don't need full desktops. I've seen cases where a desktop's simply too large for the device that people want to run it on. However, the application runs just fine on it. And like I said, if you use Linux, you can get around some of that Windows licensing costs. Where we're working now, everyone seems to be working remotely. Unified communication programs like Skype, Zoom, WebEx, these all are coupled under unified communication, and I think we've all grown to have this love-hate relationship with things like Zoom, but it's been so important to kind of allow us to interact with our teams, especially if you're working, next to someone. You kind of miss their face. So I'm on Zoom meetings, half the day. It's just the way we do business now. And these processes, they can be pretty heavy, not only from CPU standpoint, but also from a networking standpoint. In a virtual desktop, the process, of course, runs on the virtual desktop. It consumes the hypervisor's resources, like I said, the CPU and the networking on it. We've come out with some really neat things to mitigate this. This screenshot shows, that the Zoom process is using, 50% of the available CPU for this virtual desktops. They can be, very, very heavy applications. So we as an industry have found some real interesting ways to get around these problems. Right now, thin clients, zero clients, native clients, we have excess capacity on the device that's displaying the virtual desktop, and we've found things to do like with multimedia redirection, where instead of running that process on the virtual desktop, in this case it's the Zoom process, we're actually going to run that process on the device itself and use some of that unused capacity of the device to run this process. So it takes the load off of the hypervisor and puts it on the device where we have, excess capacity. And I love this screenshot. I love this graph because this is showing the CPU utilization on the device, and without MMR, we're using maybe 5% of the CPU. But if we can take that Zoom process and run it on the endpoint device where we have excess capacity, it jumps up to 50%, which is good because that's CPU cycles that aren't being taken up on the hypervisor side. So that allows us to have better guest density on the hypervisor. Also, it takes that network traffic off the hypervisor as well. Before, when you do a Zoom session using VDI, it transmits the network from your device to the hypervisor and then out. With using MMR, things like that, it goes directly from the device to the other user. Another thing we need to be aware of and monitor and make sure that we're using or that users can actually access these network resources. So we need to monitor if their desktops are available, if the gateways are available, if the connection servers are available. And so we've come up with synthetic monitoring tools. There's a bunch of different ones out there. You really need to use these. It can save you a lot of headaches if you can go out there and see if the remote applications really are accessible, so the users can do it. Nothing more frustrating than a user saying, no, I can't access my resources. But if you do synthetic monitoring testing of these resources and make sure they are available, it's a huge win because you can proactively alert your users that the devices aren't, the resources aren't available. A lot of these can go out there, and in this case, it goes out there and checks the applications, published applications, as well as the desktops. It even checks things like the DNS, make sure that it can be resolved as well. So one of the biggest headaches I've seen is really a pain point for our troubleshooting is we used to have 3,000 users in 3 locations. Now we have 3,000 users in 3,000 locations. They're working from home. This brought up a lot of challenges because when an application becomes unreachable or sluggish, workers they assume it's always on the back end. Why is my application down? They don't take into account that they have a 10-year-old consumer-grade Wi-Fi router. And even worse, that router might not have the latest encryption standards, security standards. So traffic is flowing from the device to that router unencrypted, where someone could be, monitoring that flow and, able to see this clear text that's being passed from it. So we kind of need to monitor this, and there's a lot of monitoring tools out for this as well. You can see this is actually a screenshot from one of the monitoring tools. It does a really good job because it monitors the latency from the device, Mac OS S2, to the Wi-Fi router. And this one picks up the signal strength of it. It's 81%, which is good. However, latency is, 219 milliseconds. That should be, 2-3 milliseconds. And then it goes further and it monitors the latency between the device and the desktop. This looks like it's a Citrix desktop, and overall that's 362 milliseconds. People are going to notice the sluggishness when you get that much latency in it. And this monitoring solution also goes out there and pings a known good site. In this case, it's Google, and it's 244 milliseconds round trip, but the majority of that is the latency between the device itself and the Wi-Fi router. So we know that we do have 100 milliseconds between the router and the desktop, but really the majority of it is on the consumer's side. If you don't have tools like this, I mean, it just becomes a headache. You can't point things out. Yeah, I've seen people who live in older houses that have lath and plaster walls, and it's like a Faraday cage, and so they just don't get the network bandwidth or the latency that they should. We do have some best practices around there. You need to monitor the signal strength from the home to router, from the router to the remote resource, and then the remote resource as well. Sometimes we have users that are some users are more important than others, or actually more vital than others. For example, doctors, and they absolutely positively need to get their remote resource. For example, a doctor, he absolutely needs to be able to access their desktops. Fortunately, SD-WAN companies have come out with home SD-WANs, and what an SD-WAN does is it allows you to your internet connection to go over different medias, broadband, 5G, 4G, LTE, to reach the resources they need. They're a little bit more expensive, but for certain users this is a requirement. They're really kind of cool because they use intelligent path selection. Obviously broadband's less expensive than 5G or LTE, so it uses that until it goes down. Once it goes down, then it goes to another medium, more expensive medium. It can do application-aware routing. It'll give a preference to voice over IP to the UC, and in some cases, certain devices. For example, if a company is paying for your broadband connectivity, it might give preference to your device over your kids watching, Netflix or playing games, which is kind of neat. These things are all policy-driven, so you have a separate SD-WAN dashboard, and you can set the policies and then push them down to all the different SD-WAN devices. All right, covered a lot of that. Now let's kind of dig into the infrastructure itself. Back in the day, we had composed infrastructure where we separated the compute nodes from the storage arrays. This is the way we did business. Everyone thought it was great because everything fit together like Legos. You could buy a storage array from EMC, from NetApp, whoever you wanted, and you could buy your servers from Dell, HP, IBM, and everything just plugged together. Well, the reality is it didn't really just plug together. It was kind of a pain to get things to work. Just didn't work that well. And on the storage side, it really kind of was a hassle because you had to buy these big monolithic storage arrays that had a lot of capacity, and then you consume that capacity over time, and so you had a lot of unused storage resources until you used it. Fortunately, and maybe because VDI came along, we came up with a new technology, HCI, and actually the first real killer use case for HCI was VDI. And what hyperconverged infrastructure does, it uses locally attached storage on each server node to create a pool of storage like the storage array did out of all these local devices, and this storage could be shared between all the different HCI nodes in an HCI cluster. What I really like about it is it had a central management console. You could manage these from the same dashboard, and some technologies that came around that really made this possible was we had processors that had lots of cores, and so it could support the storage, software-defined storage that HCI nodes used. Storage became a lot faster. SSD drives came online about this time, and literally one SSD drive could deliver the same amount of IOPS as an entire storage array. So they really became powerful. But like I said, the thing I really found neat about it was the management console, central management. You didn't have people who ran the storage side. You didn't have people who ran the compute side. All of it was from the same dashboard. And another neat thing was, especially with VDI, you could calculate how many users, how many virtual desktops a node supported. So if you added another 50 users, you had to add just one more node. It was real granular that way. When you look at HCI vendors, you want to look at a few things, software, hardware selection. Some HCI vendors only support certain hardware. Others have a lot of flexibility. If you're an IBM house or a Dell house, is the HCI solution, is it tied to one specific hardware vendor or not? Performance, quality of service, can you give some virtual desktops a higher quality of service when they come under contention? VDI, HCI vendors, do they support Citrix? Do they support VMware? Do they support LeoStream? Do they support whatever? So that's another important consideration when you're looking at HCI vendors. Performance, storage can be a killer. Make sure that they support, SSD, and now definitely make sure they support the number of NVMe drives that you need to get the IOPS that your users have. Turnkey deployment. Do you have to go through a lot of hassle and setup, or can you just buy the nodes themselves? Time to value. How long does it take to set these up? Things like that. Ecosystem. Are there third-party products out there that work with it? A question here. I'll get to those a little bit later. One of the interesting things that happened during the pandemic is we couldn't get the hardware that we needed to support the number of VDI users that wanted to use it. So a lot of HCI implementations have cloud connectors, so we were able to use cloud desktops instantaneously, turn them on. So that was an important factor. Went a little bit too far there. So when you consider whether you want to have HCI or Dash, you have to take into account things like a geographical location. If you are supporting users in Europe or Asia, sometimes it's better to have a cloud deployment there because it's actually closer to the users. However, a lot of companies and countries have they require the data be stored in that country itself. Governance rules actually where data needs to be stored. Performance with HCI, you can definitely define how big a desktop is. If it's on-premise with Dash, you usually get to choose between 3 or 4, maybe 5 different instance sizes to use, so you can't really do it. Also with Dash, you might not have the ability to add other hardware to it like GPUs, availability, things like that. Like I said, hybrid really is a neat technology that we're starting to see more and more people use, where you have these connectors that work with cloud desktops as well as the physical desktops. So when you're talking about VDI deployment, infrastructure planning, if you use composable infrastructure, you're going to have this huge outlay of capital when you first start up the system, and then you're gradually consume it over the time. You need to make purchases for the long time, and then for the long term, and then you do your storage array refresh every 3-5 years, but you're still buying this huge amount of storage that you're just consuming over that 3 or 4 years of time. HCI really has it's a moderate CapEx. You don't need to buy huge storage array and a lot of servers. You just kind of purchase them as you add users. You can have a quarterly purchase cycle rather than a yearly or 3-year purchase cycle, and then you consume moderately. You might have extra capacity for another 50 users that you might consume over a quarter. DAS is kind of nice because it does have this OpEx model. However, compared to some HCI models, DAS might actually be a little bit more expensive. But you can purchase it as used and you consume it as used. You can usually buy like a package of 10 desktops to do it. But with hybrid, you get this nice mix between CapEx and OpEx. You can purchase as needed, where needed, and you can kind of consume moderately. So hybrid, a lot of people are going to it. It's very attractive. HCI, very attractive for a lot of people also because of its purchase model and its costing structure. On the end user side, you need to make sure that the client matches the user's needs. You can use your native clients, thin clients, mobiles, tablets. Some work for some users better than others. Got just a few more minutes here, and I want to talk about why things have failed. VDI implementations have failed. Biggest one I see out there is people just they try and do a big bang deployment. We're going to 10,000 users. We're going to turn it on one day. That never works out like people think it is. I think it will. Start out small. Start out with a small bunch of users, and then go to the department level. And then after you gain that knowledge, you see how things actually work in the real world. Then you can go to the whole company. I/O storms were a big problem we had in the early days before we had SSD drives, because when you boot up a desktop, virtual or physical, it just pounds on that disk. You're going to use thousands of IOPS rather than the 5 or 10 IOPS that I'm using right now. So it just pounded the storage, and it actually caused a lot of people to walk away from VDI in the early days. But with NVMe drives and SSD drives, this has really gone to the wayside. Cost overruns. When we tried to do this with composed infrastructure, we bought these big storage arrays, and the numbers just didn't work out. HCI really kind of limited that exposure. And you know what? Sometimes you need to walk away with HCI. You don't have that huge upfront investment that you need to do. And like I said, you can add nodes gradually as needed. So a couple things you want to do, monitor. I think Steve Ballmer said that. You need to take a look holistically. You need real-time monitoring. Real-time monitoring is kind of a catchphrase. So when people say real-time monitoring, what does that mean? Does that mean every 3 seconds? Does that mean every 30 seconds? Does that mean every 5 years? There isn't a industry term what real-time means. So people say that, ask them what they need. If it's a longer duration, you're going to miss spikes and things like that. Nutanix Playbook, they're the ones sponsoring this. They do a great job with HCI. They have an automation playbook that can do interesting things. They have a sample there where a VM is starved for memory, sets off a trigger, takes a snapshot of the machine, adds memory to the virtual desktop, and then resolves alert. We just don't have enough people to do this manually, so whenever you can automate, you really need to. We just have too many users and not enough admins out there. You need to monitor the entire infrastructure. Like I said, you can throw resources at the back end, but it really doesn't matter if the problem is on the user side. If they're having issues, so you need to be able to monitor the whole VDI infrastructure. So in wrapping this up, benefits from using these best practices. The users will have a better experience. Nothing will sync a VDI implementation faster is if they don't have a good user experience. Using these best practices, you'll be able to have meet with your corporate and government regulations. You'll be able to meet the SLAs. Management will be easier. You'll have better security and lower costs. And man, we covered a lot of stuff in this 50 minutes. But do we have any
sure
questions
did,
out
my
there?
friend.
Oh, thank you, John.
Hi. Thanks, Tom, so much. Let's get to some of the questions from our attendees. Remember, you can type your questions into the Q&A box at any time. We'll do our best to get to all of them. I'm talking real fast because I want to get to a few of these. So Brian asks, how much does encryption degrade typical VDI session performance?
You know, it really not noticeably. There's a couple different places it can take place. From the client to the back end, encryption doesn't, maybe 1-2%. We've gotten really good at it. It's not going to be noticeable. On the back end, if you're encrypting your disk using HCI, again, our processors are so powerful that it's really kind of not a big issue at all.
Okay, Fred asks, so if your, quote, cloud-based hypervisor-based centrally managed solution, end quote, just runs apps on the edge device, what is the advantage versus traditional MDM?
A traditional what, NVM?
Yeah, MDM.
Oh, mobile device management. Okay. Well, a lot of them are geared particular for VDI. A lot of MDM, mobile device management, they take in a lot of things that you might not need for say like a thin client or a thin client. They're worried more about updating the OS running on it, putting policies, group policies, things like it. So the ones I were talking about, they just look at, how it connects to the VDI rather than doing the whole big picture of a mobile device like a laptop that someone's using at their home. So simplicity probably is the answer to that.
Cool. Okay. Blanca asks, would you take healthcare data to the cloud?
Man, great question. And actually, you need to see if it does fit in with your governance. But all the big cloud providers, they're very aware of the security aspects of it, and they oftentimes meet the regulations that can do it. But at the same time, healthcare, hospitals, doctor's office, a lot of times they just choose to run it on premise because they need that security. They just don't feel comfortable with it. So technically, yes, you could run it in the cloud, but a lot of people choose to run it on premise. And you know what? That's fine. Yep.
Okay, we're running out of time, but let's get maybe one more here from Brian. Have you ever tried double nested encryption for secure operations?
Double nest. So like a VPN with VDI over VPN, you certainly could, but there'd be really no advantage to it that I could see. The encryption standards that people, like all the big VDI vendors, is 256 AES, and I can't see a reason for doing it in 99.9% of the applications. So nope, I haven't tried it because I don't feel there's a need for it.
Well, we are all out of time. Thank you so much, Tom, for a great session. Thanks, everybody, for your questions. If your questions weren't answered, I think we have a way you can, Tom can follow up with you offline. Anyway, thanks, Tom. Really appreciate your time today.
Okay, thanks, John. Appreciate you guys having me.
We're going to take a short break right now, but we'll be back at looks like a few minutes after the top of the hour for our second session, Securing VDI and EUC, What You Need to Know, led by Microsoft MVP and technology writer Brian Posey, and moderated by my colleague David Rammel, who leads the editorial team at Virtualization and Cloud Review. Many thanks to Tom Fenton for a great session, and to our sponsor, cloud solutions provider and hyper-converged infrastructure pioneer Nutanix, for making it possible. Be sure to check out my be sure to check out my conversation with Tom on the latest episode of the WaterSearch podcast. Now would be a great time to check out those extra resources on your console provided by our sponsor. Remember, we're giving away a Surface Pro 7 to one lucky attendee at the end of the third session. You must be present to win, so stay tuned. Back in a few.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers. And, of course, our sponsor, Nutanix, for underwriting the summit and allowing us to bring you this great content. I'm David Rammel, editor of Virtualization and Cloud Review, and I'm here to moderate the second session of our summit titled Securing VDI and EUC, What You Need to Know. Our speaker for this session is Brian Posey, 20-time Microsoft MVP and technology writer. Throughout his career, Brian has written or contributed to dozens of IT books and created numerous full-length video training courses and published thousands of blog posts on a huge variety of IT and space-related topics. Many of those blog posts can be found in his Posey's Tips and Tricks column or in his new Posey's Moonshot column at redmondmag.com. Brian, it's great to have you here. Please take it away.
Hey, thanks so much for having me. So today I'm going to be talking about VPN and end-user devices. The title of the presentation is a little bit wrong here. But before I get started, I think that I need to begin by addressing the elephant in the room, and that is the way that VPN is so often perceived. Now, I know that I'm speaking to an audience of IT pros, and certainly I'm sure most of you understand the fundamentals of VPN. But I'm going to take just a minute and cover a couple of the basics just to help catch up anybody who might not be on the same page, and then I'll jump into the meat of the presentation. But the elephant in the room is the way that VPN is so often perceived, because unless you've been living under a rock, you've probably heard all of the constant barrage of advertisements that's on radio, TV, and wherever else from various commercial VPN providers that are consumer-oriented. And a lot of times, and I'm not calling out any specific company, but a lot of times these advertisements tend to be really misleading. They say that the VPN can do things like prevent hackers or keep your web provider from tracking you and make you completely invisible online. And those types of claims are misleading at best. And one of the problems with that is that even if you know better, your end users may not. So a lot of times there's a false sense of security that goes along with using VPN. So what I want to talk about in this presentation is how to get past that and what you can do to make sure that things are more secure than they otherwise might be. So the reality of the situation is that VPNs give you privacy, not security. And there is a big difference between the two. That's something I'll be talking a little bit more about as we go along. And, of course, there are two main types of VPN, Internet VPNs and the corporate VPNs. So let's just take a look at the two types very, very quickly, and then we'll get into end-user device management. So from the Internet VPN perspective, the way that this works is that you've got an end user that's probably sitting at home or maybe in a coffee shop or a hotel or airport. They could be anywhere. And this user wants to securely connect to the Internet. So rather than connecting directly into an ISP, they connect to a VPN server instead. And they establish a secure tunnel with that VPN server. And then whenever the user makes a web query, that query gets passed to the VPN server, and then that VPN server reissues the query from itself, so that ultimately that query looks like it's coming from wherever that VPN server is and from that VPN server's IP address. So this does mask the IP address of the client who initiated the query, but it certainly doesn't make the client invisible, because there are any number of things that a web host could do to determine the end user's identity. There are tons of different tricks for that. So Internet VPN definitely doesn't make you invisible. So what about corporate VPN? This is the main thing that I want to talk about in this presentation. So a corporate VPN is, of course, quite a bit different from an Internet VPN that's geared towards consumers. Once again, you've got a user who's working remotely, could be anywhere, and they use their Internet connection to connect to a corporate VPN server. Now, that corporate VPN server does a couple of things. First, it typically reaches out to a radius server or some other authentication mechanism to authenticate the user's identity. Another thing that it does is it provides the end user with an IP address that's suitable for use on the corporate network. And then at that point, the corporate VPN ends up giving access to the corporate network, just as though the user were connecting their device directly on premises. So that's just a very, very quick overview of VPNs and how they work. So I really want to get into the security aspect of this. Now, at the very beginning, I mentioned that there was a big difference between privacy and security. Privacy comes in the form of encryption. It simply means that all of the traffic between the user and the VPN is encrypted. So the user's web provider or anybody who happens to be sniffing internet traffic can't see the contents of the packets that are flowing back and forth. Simple enough. But this is different from security because the end user's device may have certain vulnerabilities on it, and those vulnerabilities don't go away just because the user is connecting through a VPN. Those vulnerabilities are just as prevalent on a VPN connection as they might be if the user were to plug their device directly into the corporate network on premises. So what types of vulnerabilities? Well, it could really be just about anything. It could be a device that's infested with ransomware or other types of malware, perhaps an outdated operating system or a jailbroken operating system. The user might have insecure applications that have been installed on their device. They might be running a really bad security configuration. For example, they might have the firewall disabled. They might not have an antivirus application running. There could be any number of different security risks that are posed by that device. So why does any of this matter? Well, if you think about it, the vast majority of the world's knowledge workers are still working remotely, typically from home, but again, could be anywhere. And these users, although some are using devices that have been issued by the company that they work for, many are working from personal devices, just like what we had during the BYOD revolution several years back. So you've got end users who are very often working from personal devices that could be running virtually any operating system and any type of configuration and might have just about anything installed on them, and they're using those untrusted devices to access the resources on your network. So this presents some really big challenges. For one thing, you've got this huge dichotomy of devices. Users could be working from just about anything. So how do you apply blanket security policies across a really diverse collection of devices? That's kind of hard to do. Additionally, these devices can't be domain joined because, one, they're typically, or I shouldn't say typically, but oftentimes not running Windows, and only Windows devices can be domain joined. Second, they're not owned by the organization, and typically organization ownership is a requirement for being domain joined. Now, why does domain joined matter? Well, when a device is joined to a Windows domain, that means that device can be locked down using group policies. And those group policies can't be applied if the device isn't joined to a domain. So if you've got this vast collection of end-user devices that are all wildly different from one another and typically personally owned, how do you make sure that when those devices connect to your network through a VPN, that they're not posing a threat to you? That's the big challenge. So how do we address this? Well, typically there's going to be a two-pronged approach that you're going to have to take to enabling security. The first thing that you're going to have to do is to apply end-user device security. And this is very similar to what you did in a BYOD environment. The fact that these devices are now connecting over a VPN as opposed to being directly connected to the Wi-Fi in the office is kind of irrelevant at that point. The other thing that you're going to have to do is take a look at what types of security features are available on your VPN and utilize those features as appropriate. This one's a little bit tougher because the features that are going to be available vary widely based on who your VPN provider is. So I'm going to show you some of the techniques that I like, but these are just some of the different techniques that are available. So the first thing that I want to talk about is device enrollment. And for this, I'm going to be using Microsoft Intune running on the back end. So device enrollment, the way that I like to think of this is an alternative to domain joining. Because remember, in order to domain join a device, it has to be running a supported version of Windows, typically Windows 10 Pro or Windows 10 Enterprise. Older versions of Windows are also supported, but we won't talk about things that aren't supported. So when you enroll a device, what you're really doing is an alternative to domain joining that device because you don't want to be domain joining personal devices even if you're able to. Now, this is something that a user can do on their own, assuming that you've gone in and done some basic setup to make it possible. And there are a few different ways of doing this, but the main way that it's usually done is by downloading an app from the App Store called the Company Portal. Now, in the case of this slide, I've got a Windows 10 device, and I've opened the Windows App Store and searched out the Company Portal. So this is a Microsoft application, and it just cracks me up that they put a rating on there, E for everyone. And so the user would go in and download this device. This is something that they would do on their own, not something that the IT department has to do for them. So once the users acquired the application, they launch the application, and the experience that they're going to receive varies a little bit depending on which platform they're working on. So things are going to be a little bit different for an Android user than, say, a Windows user or an iOS user. But these particular screen captures were taken from a Windows device. So the first thing that the user sees is a prompt to log in using their corporate account. This is the same account that they would use to log in to a device on premises. So at this point, the user provides their login name and their password. And next, the user is going to see the screen right here asking if they want to stay signed into all of their apps. Now, the important thing about this screen is the checkbox that you see next to the big blue arrow. And this checkbox, which is selected by default, is allow my organization to manage my device. So assuming that the user leaves this checkbox enabled, then the organization is going to be able to apply security settings to the device similarly to what they would be able to do with a domain joined device. The big difference, of course, is that they're not going to be able to use group policy settings to do that. Instead, they're going to have to use security settings that are enabled through Intune. So at that point, the user enters their credentials. They confirm that they want to allow their device to be managed. And then they're taken to these screens right here. This is the setup process. It takes a couple of minutes. And then after a moment, the user receives a message saying, "You're all set." And they just click Done, and the process is done. At that point, the device is enrolled. Now, the user's not quite done because they open up the company portal, and they see a screen kind of like this. And if you look toward the center portion of the screen, you'll see a warning message saying the device hasn't been set up for corporate use yet. Select this message to begin the setup. So at this point, really the only thing that the user has done is they've installed the company portal app, and they've provided a set of login credentials and confirmed that they do want to allow the device to be managed. There's still a little bit of work that has to be done on the end user side. So the user taps this message, and then they're taken to this screen. And this screen tells the user that this is going to be a three-step process. So the first step they've already done, and that's to add a corporate account to the device. You saw what that looked like a couple of screens back. The second step is to connect the device to work. And then the third step is to choose a category for this device. So the user taps Next, and then they're taken to the Connect to Work screen. At this point, the user doesn't really have to do very much. They simply tap Connect. They're prompted one more time for their credentials, and then that step is done. So now the user is taken to a screen where they're asked to select a category for the device. Now, categories are a little bit interesting because they don't exist by default. So before the user ever enrolls a device, it's a good idea to go in and set up some categories if that's something that you want to do. So let me show you how that works. Now, as previously mentioned, I'm basing all of this on Microsoft Intune. And Microsoft has a management interface for Intune called the Microsoft Endpoint Manager. So you can see the Microsoft Endpoint Manager Admin Center on this slide. So if you want to set up categories, what you have to do is go to Devices, and then go to Device Categories, and then click on the button that you see in the center portion of the screen, Create Device Category. And this is a really simple process. When you tap that, you're taken to this screen right here, and the first thing that you'll want to do is enter a name and a description for the device category that you're creating. And in this case, I'm just going to create categories for personal and for company-owned devices. That might not necessarily be an organizational structure that works in your environment. You might create categories based on operating system or based on the user's job function. You can really create categories in any way that you want. The interface doesn't limit you in that way. One thing that I will say, though, is that I'm personally a big believer in descriptions. The vast majority of the time, Microsoft makes descriptions optional when you're populating a field like this. But by going ahead and populating that description with some really good descriptive text, it makes it a lot easier for whoever comes along behind you to figure out what it is that you've done and why this particular policy, or in this case category, exists. So enter the name and description, And then you're taken to the scope tag screen. So the interesting thing about creating a category is that the category doesn't really do anything except map a tag to the category. Tags are something that's used in cloud computing just to assign an attribute to an object to make it easier for those objects to be organized. So what you're really doing here is you're creating a category name and you're appending a tag to that name so that you can sort these out a little bit later on. So once you've assigned a tag, then you're taken to this review and create screen. Just take a moment, look it over, make sure everything looks good, and then click a create button, and then that category is created. You can see on this screen right here that I've created two categories. I've created one called personal, and I've created one called company owned. And again, this is something that you would want to do before the user ever begins to enroll a device. So if I click back over to the end user enrollment screen, you can see that those categories that I created show up on the user's device. So at this point, the user simply selects the category that best applies to them. In this case, if the user were working from a personal device, they would want to choose the personal category and then click done, and then the enrollment process is complete. So from the end user perspective, they're all done here. They can begin to use their device on the company network. So as you can see, we can see the devices, we can see recently published apps, which there aren't any right now. I'll show you what that looks like a little bit later on. So what does this look like from the back end? Well, when the user enrolls a device, it makes that device available for management. So as you can see right here, I'm back in the Microsoft Endpoint Manager Admin Center, and what I've done is I've gone to all devices, and you can see the device that I've just enrolled. And let me move to the next slide because I've got a zoomed-in view of this, so you can see the types of information that's shown for the device. We have the device name, which is usually a semi-random value unless the user happens to have assigned a custom name to their device. We can see that the device is managed by Intune. From there, we can also see the device ownership. In this case, that's shown as unknown. Now, remember, when we set up the personal and company-owned categories, those categories just map to tags. They actually have nothing to do with device ownership. So the ownership attribute is something that you would want to go in and set manually later on if need be. Then we have compliance, and we can see that this device is compliant with our policies. Now, the interesting thing about this is that the Microsoft Intune allows you to create various types of security policies. And you can have Intune tell you if a particular device is compliant with those policies or not. And I'm going to be showing you how to do that later on as we go along. But the important thing that you need to know right here is that at the time that I took the screen capture, no policies existed. So the device is listed as compliant even though there are no policies. So compliant is kind of the default state until you begin creating policies. And even then, another important thing that you need to know is that it can take a little bit of time for a device to be evaluated against newly created policies. So as we move on to the other columns, we see the operating system that's running on the device, in this case Windows, the operating system version, and the last time that the device checked in with Intune. And so here you can see the device time that it checked in, which was about 10:30 last night. So let's talk about device compliance. I've already shown you how Intune can show you if a device is compliant or not, but what does it really mean for a device to be compliant? Well, as I mentioned a moment ago, Intune allows you to create compliance policies. And the way that you would do that is by going to the Devices tab, and then from there you would click on Policies, and then click the Create Policy button, as you can see in this slide. When you click that button, you're taken to a screen that asks you to create a policy. The first thing that you have to do is to choose the platform that you want to base the policy on. And the reason for this is that there's not a lot of consistency among different device types. For example, the security settings that might exist for a Windows device aren't necessarily the same as the settings that are available on an Android device or an iOS device. So rather than simply creating a blanket policy and applying it to all device types, Intune is very specific in that it asks you to choose which type of device you want to create this particular compliance policy for. So you could conceivably have a very different compliance policy for a Windows device than, say, an Android device. But let's take a look at the policy creation process. So as I mentioned, the first thing that you have to do is to select the platform. I'm going to go with Windows 10 and later in this case. Then you select the profile type. Now, because we're creating a compliance policy, Intune already knows that that's what we're doing because we clicked on the compliance policy option. So the profile type is grayed out. It's always going to be set to compliance policy because of the way that we went into this interface. So the next screen that you see asks you some basics. You have to provide a name for the policy that you're creating, and again, you're prompted for a description. And the platform and the profile type are grayed out because you selected those earlier. So next you're taken to the compliance settings screen. And this is where you begin to define what it means for this particular device category to be compliant. So we have all of these categories. You see device health, device properties, configuration manager compliance, system security, and Microsoft Defender for endpoint. So you can go in and you can adjust different settings within these different categories and define what it means for your devices to be compliant. Let's take a look at a few of these. So here I've expanded device health, and we can see a few of the options that are available. We have require BitLocker, require secure boot to be enabled on the device, and require code integrity. Now, one very important thing that I want to mention about this is that when we set these particular settings, we're not actually enforcing these on the device. We're only saying that if this device is to be considered compliant, then these settings need to be set up. So this is something that the end user would do. Just by setting these particular settings doesn't automatically turn those on in the device. That's done in a different way that I'll show you a little bit later on. So we also have device properties. And here we can set a minimum and maximum operating system version for both desktop and mobile operating systems. So if you wanted to make it so that only Windows 10 or Windows 11 devices were supported and not, say, Windows 7, Windows 8, Windows XP, you could do that right here. And then there are some additional categories that are available. For example, Configuration Manager allows you to tie this into System Center Configuration Manager. System Security, I'd have to go back and look, but I believe that one allows you to specify password requirements for the device. And then we've got Microsoft Defender for endpoint. So Microsoft Defender for endpoint establishes what's called a risk score for the device based on how risky it considers the device to be. So you can make it so that if this device is to be considered to be compliant, then it has to be at or below a certain risk score threshold. So the next thing that you have is actions for non-compliant devices. So you can create several different rules here. So the very first thing, and this happens by default, is that when a device is found to be non-compliant, the device is marked as non-compliant. So what that means is that as you go through the console, you'll see that device listed with a non-compliant status next to it. And that happens immediately upon discovery that the device is non-compliant. That's always going to happen, but it's up to you to decide what happens next. So your options are send an email to the end user or just simply retire the device. In other words, don't allow it to participate within Intune. Don't consider it to be a managed device anymore. And it's up to you how you want to handle this. And you can also handle whether those changes kick in immediately or if you want to delay it. Next, you have the option of assigning this policy. So what devices do you want this particular policy to be applied to? In this case, we're creating a Windows policy, but that doesn't mean it's automatically going to apply to all Windows devices. You can pick a particular group of devices and apply that policy specifically to that group rather than just applying it to all Windows devices. And then you can review and create the policy. And then once the policy has been created, you're taken to a screen right here, which shows you all of the various policies that you've created in your environment. So what happens if you click on it? Well, if you click on the policy, you're taken to an overview screen like the one that you see here. And the thing that I like about this screen is that it gives you this really nice dashboard view so that you can see what's going on in your environment. For example, the chart that you see on the top, I know it's probably a little bit hard to read on your screens, but this is the policy assignment status for Windows 10 and later devices. And then the one below that is the policy assignment status for Windows 10 and later users. Now, as you look at this, you'll probably notice that the policy hasn't been assigned to any devices. even though if you look at the top of the screen, you can see that the assigned indicator is set to yes. So this policy has been assigned, and it's been assigned to one group, but right now it hasn't been applied to any devices. And the reason for that is that when you create a new policy, there is a little bit of a lag from the time that the policy has been created until that policy actually begins being applied to the devices within your organization. So if I click on device status, you can actually see a device that is linked to that policy. This is the device that I enrolled earlier. And if you look at the compliance status, you can see that it's listed as not evaluated, meaning that Intune hasn't had a chance yet to go in and look at that device and evaluate it against the policy that you've created. So at this point, the compliance status of the device is a bit of an unknown. Now, one of the cool things that I really like about this particular interface is that if you click on the device, you're taken to a screen like the one that you see here. And this gives you a chance to kind of get an overview of the device. So in this case, for example, we can see the device name, the management name. If ownership has been set on the device, we can see who owns it. We can see the device's serial number, who the primary user is, whether or not the device is listed as being compliant. And then additionally, if you look at the very top of the screen, the area with the big blue oval around it, there are some actions that we can take on that device. For example, if we want to retire this particular device, even though it's still listed as being compliant, there's an icon we can click on to retire the device. There's also options for performing a remote wipe. You can synchronize the device. You can force the device to restart. And then the options on the right, you can perform a quick scan or a full scan using Windows Defender, so you can check the device for malware. And as a matter of fact, if you look at the bottom of the screen, you can see that I had initiated a Windows Defender quick scan, and you can see that the status of that was complete. So this gives you a way of finding out what types of administrative actions have been performed recently, or maybe not administrative actions, management actions, security actions have recently been performed on the device. So a couple of other things that you can do through here, and this has a little bit less to do with the topic of security, but they're handy anyway, so I thought I would show you. There's a hardware tab, and if you click on this tab, you can get an overview of the hardware that is on the device. So you can see things like the device operating system, the total amount of storage and free storage available in the device, and some various other attributes. You can also get a feel for the end-user experience, and I absolutely love this. So you can see a chart of the device's startup performance. You can see application reliability, and some various metrics that can be helpful to help you quantify how well the device is doing with regard to the overall end-user experience. So let's talk about security policies, because thus far we've been looking at compliance policies, but security policies are a little bit of a different animal. So let's take a look at how that works. So this is the screen that you would use to create a new security policy. And the way that you would get there is by clicking on Devices and then going to Overview. And then there are three columns that are in the main part of the screen. And the center column is Simplified Security Policies. And the nice thing about this is that you don't have to go in and manually set up a security policy for one particular very granular aspect of security. Microsoft has already gone through the trouble for you of creating these simplified security policies. And I don't even really think of them as simplified because, truthfully, they're not that simple. There's typically a lot of different settings that are available for you within those security policies. They're just simplified from the standpoint that you don't have to create them from scratch. You've got a template that's available for you that can help you through the policy creation process. So what types of security policies can you create? Well, it's going to vary depending on the device platform. So the options are going to be a little bit different depending on whether you're using an Android device, an iOS device, a Windows device, or what have you. But you can see things like antivirus, disk encryption, firewall, attack surface reduction, endpoint detection and response. So these are some very useful security policies. Let's take a look at what's involved in creating a firewall policy. So if you click on Firewall, you're taken to the Endpoint Security Firewall screen. And then there's a Create Policy button that you would have to click to begin the policy creation process. So the first thing that you would have to do is select the platform and then select the profile. And again, this is going to be filled in by default, especially in this case because we're already working with Windows 10 devices. And we clicked on Firewall, so Intune already knows that we want to create a Microsoft Defender firewall profile. So then we're taken to the typical Microsoft screen that you've seen several times already throughout this presentation, where you provide a name and a description for the profile that you're creating. And again, platform is grayed out because we've already provided that. Next, we're taken to the Create Profile screen, and this is where you go to enable the various security settings. Now, here's an important distinction. Earlier when I was talking about device compliance, I mentioned that the settings that you implement are designed to evaluate whether the template settings that you provide match up with the settings that are on the device. And by comparing those settings, you can find out if the device is compliant. What we're doing here is different, because rather than evaluating whether a device matches up to your security requirements, we're actually applying security settings to the device. So think of this as being sort of kind of in line with group policies. We're implementing policy settings, and then we're applying those policy settings to the end user device. Remember, when the user enrolled that device, there was that checkbox that I showed you earlier that gave you permission to manage the device. So this is where that management comes into play. So what types of things can you do? Well, pretty much anything that you could do on the local desktop with regard to configuring a firewall, you can do here. I've included some of the available settings on the screen just so that you could get a feel for it, but the settings actually scroll way beyond the boundaries of the screen, so there's a lot more than what you see right here. The big blue arrow that's in the upper right portion of the screen points to a setting to turn on the Microsoft Defender firewall for private networks, and I've set that to yes. And the only reason why I did that is just to illustrate the idea that there are some really basic settings that you can use to check the device, like, oh, hey, is the firewall enabled? No, well, then go ahead and turn it on. That's how you would do that. So once you've gone through and you've established the settings that need to be applied as a part of that profile, there's an opportunity to assign scope tags, just as we did earlier when we were creating those device categories. And scope tags are optional. You don't necessarily have to apply scope tags, but they can be handy. And so then we move on to the assignment screen. Once again, this policy isn't going to be assigned to everyone by default. You have to choose which groups you want to apply the policy to. And you also have the option of excluding groups if you want to. So if there are certain groups that you want to make sure that this policy doesn't apply to, you can configure that right here in the exclude groups section. The only caveat to that is that you have to make sure that there is no overlap between the groups. So you can't have a user who happens to be in your include group and your exclude group. That doesn't really work. So then the last screen is the review and create screen. You would want to take a moment and just make sure that all of the settings that you've implemented match up to what you thought they were. Make sure you didn't make an errant click or anything. And then you would create the policy. You can see what the completed policy looks like right here. So what about VPN? Right now I've spent a ton of time talking about end-user device management, but I haven't really brought VPN into the picture all that much. Well, you've got to remember, Microsoft Intune is more geared towards mobile device management and less toward VPN, but that doesn't mean that there isn't any overlap available. There are several things that you can do with regard to VPNs in Microsoft Intune. Specifically, you can configure Intune to deploy a VPN client to the end-user devices. That's certainly something you can do. If you think back to the company portal site that I showed you earlier, you'll recall that there was a section for applications that were available. So if you set up a VPN application, you can actually make it appear on that screen to the user so that the user is able to simply tap on that VPN application and then have it installed to their device. It's something that can be really handy for a user because they don't have to go out and figure out where to download the VPN application. It's presented right there for them, and it makes things a lot easier. Another thing that you can do is you can configure the device for automatic VPN connectivity. In other words, you can go ahead and specify all of the connection settings that need to be put in place so that you greatly simplify the process of connecting to the VPN for the end user. So let's take a brief look at how both of these work. So the first thing that I want to show you is how to deploy a VPN app to the device. So what you would do is you would go to Apps and then click on All Apps, and then click on the platform that you want to deploy the application on. In this case, I'm going with Windows. From there, you would click on Add, and you can see that right now there's one Windows app that's already in place, Messenger, but you can add additional applications. And you can pick from a variety of different application types. For the example that's coming up, I'm going to show you how to deploy a Microsoft Store app, but certainly that's not the only option. You can deploy Microsoft Edge, you can deploy a Windows 10 app, you can use a web link, you can deploy a line of business app. So you've got a lot of different options here. You have a ton of flexibility. But as I mentioned, for this particular example, I'm going to use a Microsoft Store app. Now, if you look at the screen, you can see that on the right side of the screen, I've gone to the website associated with the Microsoft Store. And what I did was I clicked on the search icon in the Microsoft Store, and I just typed in VPN. And I picked the first one that I saw, which is the Azure VPN client. But there are a lot of others. And then, of course, if you have your own VPN application, you can certainly use that as well. I'm just going with a random example right here. But what I'm doing from here is I'm taking the URL that's associated with the Azure VPN client, and then I'm pasting that into the App Store URL field, which you can see on the left side of the screen. The left side of the screen is the interface that's presented for you within the Microsoft Endpoint Manager. So from there are a lot of other fields that you can populate. You can provide the application name, a description. You can enter who the application publisher is. You can set a category for the application. You can provide an informational URL, even a logo for the application. So you can really fine-tune this and make it nice and neat for your end user. So once you've done that, then you would click Next. You're taken to the assignment screen. And then once again, you have to pick who this particular application is to be made available to. So you would click on Add Group. You would choose the group that you want to make this application available to. And then you would be taken back to the screen once you've added a group. And then you're taken to the Review and Create screen where you would go over the settings that you've implemented, make sure they're correct, and then click Create. And then at that point, the application becomes available to the users within the group that you've specified. So the last thing that I want to talk about is VPN connectivity. So as I mentioned earlier, you can actually set up Microsoft Intune to know what the VPN settings are that are necessary to connect to your corporate VPN so that those are automatically available to users. So the way that you would do that is to go to Devices and then click on Configuration Profiles. I've drawn blue arrows pointing to both of those options. So when you get to the Configuration Profile screen, it's going to look like this. You would click on the Create Profiles button. And then what you see next is going to vary considerably depending on which platform you're working on. In the case of Windows 10 or later, you can actually pick a templates option, and then there are a number of different templates that you can use to configure different things. With some of the other platforms, you would simply have to select VPN from the profile type as opposed to selecting templates. But in this case, what we would want to do is choose VPN from the list of template names. And then once we do that, we're taken to the screen right here, which walks us through the process of setting up a VPN configuration. So again, we begin by entering the name that we want to assign to this configuration. I just called it VPN. And of course, you would enter a description. Then you are taken to a screen where you can enter the actual configuration settings. Now, obviously, not all of these settings are going to fit on this screen, so I didn't expand all of these categories. But you can see that we start with the basic VPN configuration options, things like the connection name, a link to the server that you're connecting to. You also get to choose if you want to register the IP address of the internal DNS, what type of connection you want to use. And then from there, you can go on and define things like apps and traffic rules, conditional access, DNS settings. If you use a proxy server, that can be set up. You even have an option for split tunneling. which if you're not familiar with split tunneling, that's something that's been gaining quite a bit of traction lately with regard to Microsoft. Because what a lot of organizations are finding is that a substantial amount of their VPN bandwidth is being eaten up by Microsoft 365 traffic. So what split tunneling does is it allows you to redirect certain types of traffic directly to the internet rather than passing that through the VPN. So you might choose to, say, route all of your Microsoft 365 traffic directly to Microsoft 365 rather than going through your VPN and then out to Microsoft 365. Ultimately, it makes things just a little bit more responsive for the end user because there aren't quite so many hops involved, and it offloads some of the traffic from your VPN. So that's something I would encourage you to explore if you haven't already. So after that, then you would go through the motions of picking a group and assigning tags if applicable, and then creating the policy. But I am just about out of time, so at this point I'd like to open it up for questions and answers.
Okay, great. I would like to remind the audience that we can answer questions until about 5 minutes to the top of the hour in order to give you a short break before the next presentation, so send them on in. So let's get started. Here's a question in the Q&A box. Why do you have to create separate policies for each device type?
Well, it's because all of these different platforms are made by different vendors. You have Windows that's made by Microsoft, you have Android that's made by Google, you have iOS that's made by Apple. And because each one of those are independent companies, they all kind of have their own way of doing things. So a security setting that might exist on, say, iOS, for example, might not necessarily exist on Android or Windows, or it might be implemented differently. So if Intune simply had a blanket policy that applied to all device types, they would be extremely limited in the types of policy settings that they could apply because they would be limited to choosing policy settings that exist on all of the different platforms. By breaking that out into separate platforms, they can expose all of the different policy settings that are supported on each platform. It just gives you a little bit more administrative control.
Okay. And I think this is about your presentation in general. Could this be considered a modern replacement for the old active sync policies?
Yeah, it's funny that you ask that because back when Exchange Active Sync first started catching on, it was quite a ways back, there were settings that were exposed through Active Sync that more or less took the place of group policy settings. They could be applied to mobile devices. For example, you could use Active Sync policy settings to require a password on the device or to disable a device camera. Well, a lot of the settings that are exposed through Intune actually build on those old Active Sync policies. They aren't called Active Sync policies anymore, but under the hood, they're very, very similar to what we had back then with Active Sync policies.
Okay. I'd like to remind the audience that we have plenty of time for questions, so send them on in. And here's a question or comment from Russell in the audience. He says, my company refuses to implement split tunneling. Are they just paranoid, or do they have valid security concerns?
I would have to chalk that one up to paranoid because, well, let me take a step back. Split tunneling can actually be used for virtually any web application, but Microsoft 365 seems to be the one that's used most commonly these days. The thing that you have to remember is that Microsoft 365 traffic is encrypted by default. So it doesn't really matter that that traffic isn't being passed across a VPN and being encrypted there because it's already being encrypted just by Microsoft 365. So you're not really gaining anything by passing that traffic through the VPN.
Okay. Here's a question from Blanca. When you apply a profile to a group, is the user unable to make security setting changes in his or her desktop?
It kind of depends on the platform, but generally what would happen is if a user goes in and makes a security change and that security change is counter to something that you've implemented, then if it's a security policy, then the next time that that device connects to the company portal, that setting will just get changed right back to the way that you had it. But if it's something that violates a compliance policy rather than a security policy, then it will simply show the Intune administrator that the device has fallen out of compliance. It won't actually go in and alter that setting. So it kind of depends on which setting gets changed.
Okay. I'd like to remind the audience we have about 4 or 5 more minutes to answer questions, so please send them on in. Here's one. Is there any way to do this? I'm not sure what this refers to. Is there any way to do this without using Microsoft Endpoint Manager?
Yes, there is. And I'm assuming by this we're talking about mobile device management. There are any number of third-party platforms that can be used, but even within the Microsoft ecosystem, there are ways of doing it without Intune. Intune makes things vastly easier, but there's something in Windows Server where you can set up a network policy server, and you can do a lot of the same types of things. The user logs in to the VPN, and the network policy server is able to run a check and see if that device is healthy based on your definition of what it means for the device to be healthy or in compliance. And then if the device is found to be out of compliance, then depending on what it is about that device, it can sometimes be remediated automatically and then led onto the network, or it can be denied access altogether, depending on how you choose to do that. But the thing about it is that it's an extremely long and tedious configuration process, and it's not something that's super well documented. And I believe I had read somewhere that Microsoft is doing away with this particular capability, so I'm not sure how much longer that's going to be available.
Okay, yeah. Long and tedious is not usually something we strive for.
Yeah, Intune is a much better solution because it has a lot less potential for human error.
Okay, switching to a more general topic, it seems like for login methods, the two primary methods are SSO and multi-factor or two-factor authentication. Can you speak to the pros and cons of those two alternatives?
I don't think they necessarily have to be mutually exclusive. Depending on which SSO platform you're using, you can have multi-factor in conjunction with that.
Okay, so do enterprises typically choose one or the other? Do they use them both in conjunction, or how does that usually work?
I've seen them both used in conjunction, but I've also seen organizations that tend to use one or the other. I would say in this day and age with so many users working remotely, multi-factor tends to be the preferred method if it has to be one or the other, simply because the users are outside of the office and there's a little bit more risk involved, so you want to check and make sure that that user really is who they claim to be and that somebody hasn't simply stolen the user's device.
Okay. I just learned about a new VPN security precaution called a kill switch. It says the kill switch ensures that if the computer loses a VPN connection, either the internet connection is shut down or the apps that are using the connection are shut down in order to prevent the internet address from being exposed. Do you have any thoughts on kill switches?
I haven't been exposed to that particular type of kill switch. I've seen a couple of others that were called kill switches, but they were absolutely nothing like what you're describing. So I'm not really sure, how to comment on that just because it's something I haven't been exposed to.
Okay, that's something we can check out later. All right, one last question. The summit dealt with VDI and VPN, and I was just wondering, what do you think is the best approach for an enterprise to support remote workers, VDI or VPN?
Once again, I don't think they have to be mutually exclusive because with VDI, you're just talking about virtual desktops. Those virtual desktops can be hosted anywhere. They could be up in the cloud. They could be in your on-premises environment. But if you've got users who are working remotely, they have to do something to get to that VDI environment. So, one option is to set up a front end somewhere and just have users connect to that front end and then sign in there and then log into the VDI environment. The other option is to use a VPN to get to the VDI environment. It's kind of two different methods of reaching the same point. I think it really comes down to licensing cost and bandwidth. Sometimes VPN may end up being a more expensive option if your VDI environment is fully capable of allowing remote users to access it without needing a VPN, and you don't yet have a VPN, you may not want to incur that additional cost of licensing a VPN and setting it up. But if, on the other hand, you've already got a VPN and it has adequate bandwidth to support the user load for all those users who are coming in and accessing the virtual desktops, there's no reason not to use it. So I think it really just boils down to use case.
Okay, well, great answer. Well, that's all the questions we have time for. So thanks again, Brian, for that excellent presentation and answering those questions.
Yeah, and hey, going back to the kill switch question, the listeners might get a kick out of this one. There was a time when I had a gig evaluating different types of firewalls, and somebody said that they were sending me, I won't name the product, but it was being marketed as the ultimate firewall with a kill switch. So I didn't really know what it was ahead of time. I'd get this thing in the mail, and it was, I kid you not, a Cat5 cable with a toggle switch on it so that if an intruder was detected, you flip that switch and it just shuts everything down.
All right. Great way to end the presentation. Okay, everyone.